Hello everyone. Today I will be just highlighting some of the concepts of data centers, commissioning stages. So that's the first topic I want to discuss today. Commissioning stages of data center, like before it's being built, or the different stages of commissioning and the levels and the tagging you give. You have level 1, level 2, level 3, level 4, level 5. And remember this, our rig verb. So it's red, yellow, green, blue, and white tag. So level 1 is a red tag, and it's a factory acceptance testing. So where you have all the systems which are being used in the data center before they arrive on site, they will be tested on the factory premises. So that's the factory acceptance testing. So they meet the standards, the quality analysis, quality assessment is done, QA/QC, regular checking, and the process is done, so to ensure proper compliance of all the materials being used in the data centers. And that's the first level, red stage. And you have level 2, that is the yellow tag. Yellow tag is again the on-site verification. Like you have a XYZ site allocated for the data center construction, and all the materials are to be brought to this site. So that's the on-site verification, the site conditions, the stages. The site is being ready to accept the materials and get the work started. Level 3 is where the magic happens. I mean, it's the start of the magic. Level 3 is the green tag. So you have the red, level 1, yellow, level 2, green tag is level 3, which is the system construction verification. So in this system, I will be reading out here because this is a critical juncture at this point. You have the green tag, commissioning and program impact. You have this level 3 before it starts. This site will need power and water. So for the data center to be ready, implemented on this stage, green tag, we need power and water. Specific transformer will be operational ahead of the others to energize other equipment for testing. All pipe work must be flushed and water filtered before testing. It's a 2-week process approximately. We need the pipe work because if we are using chill water systems, any kind of hydronic systems, the pipe work must be flushed because there could be impurities, debris. You don't want any clogs, you don't want any loss of heat transfer, any losses or problems in the water system. So all pipe work must be flushed and water filtered. And then low voltage systems are installed, like CCTV access control. You have gate barrier, you have BMS automation, alarming, alerting systems. These are the systems which will be installed in the data center being assigned. And then network wiring and cable is a very critical part for the racks and the network router switches. Network wiring and cable routing will take place in level 3, where you have the backbone skeleton structure being laid out. Level 4 and level 5 are the more critical final stages. Level 4 is the RYGB is level 4. Blue tag is level 4. Blue is the level 4. And this commissioning phase requires buildings to be in the finished state or completed state. The building should be completed. The construction should be done, handed over. The power, electricity, waters, everything. The utilities should be ready for operation. The groundwork is laid. The testing, commissioning is done by the HVAC, plumbing people, and the utilities team and the general contractors are all out of the building. They've completed the job. Level 4 is that phase, commissioning phase. It requires the building to be finished. Level 4 heat load testing replicates a full server load on the cooling system, requiring power and cooling equipment to be fully operational. Level 4, basically you are actually simulating and testing a full load condition on the building. Like you have maximum amount of servers that this building can handle, this data center can handle 100,000 servers. Example, you are testing it on a full load, making sure that the cooling system maintains that load. It doesn't crash out, it doesn't cause a failure in the system, and it requires power and cooling equipment to be fully operational. Obviously, you need power and you need the HVAC chillers, air handling units. You have the Liebert, Stolz units, whatever units you're using, they should be fully operational, and testing scripts to be provided. And level 4 will be repeated for later phases. and that's level 4. Level 5 is the final stage, rig above, red, yellow, green, stage 1, stage 2, stage 3, red, yellow, green tag. Blue tag is level 4. Fifth is the white tag, as we have mentioned. The final level 5 white tag. This level 5 will check the system's interactions and operational in real-time conditions. This will ensure the systems or interactions and operations are happening in a real-time condition, like you have servers running and you need this much amount of coolant, and all systems are operational on a real-time condition basis. Level 5 may not be carried out in later phases due to the risk of UPS switching while operational. We don't want to carry out these testing stages on a later date or time, because the UPS and all the redundancy systems, you don't want them to kick in when you're testing. So final stage, this is the final stage in the data center handover, level 5. So that completes the level 1 to level 5. So basically level 1 to level 5, red, yellow, green, blue, white, and these are the tags L1 to L5. Hopefully that explains the initial levels of commissioning for the data center. Coming to the next part, I want to discuss regarding the ISO guidelines which are being used for data center. These are international guidelines. They are ISO 22237 series. So basically, this is critical. We need to understand what international guidelines, what are you following these systems, what are the different guidelines, why do you want to select this particular equipment, why do you want to select this particular cabling, what is the method, what is the right way to proceed with the different stages for electrical power, communication, HVAC. So you need guidelines, and this is ISO 22237. This is the guidelines we use, and that's the next important topic. Basically, we have compliance of NFPA 75 for fire. This is very critical, just for our reference. NFPA 75 for fire, ISO 22237 for the data center international guidelines, and EN 50600 for Europe. So international is ISO 22237 and EN 50600 for Europe. International standards, ISO IEC 22237 is global, and it provides framework for worldwide data center planning and operation. If anybody asks what are the ISO guidelines and what are they used for, ISO 22237 is a global international standard guideline. It provides frameworks for worldwide data center planning and operation. That's very important to remember. ISO 22237 is a global international standard. It provides framework for worldwide data center planning and operation. And common focus areas in guidelines are IT and environment, optimizing server efficiency, temperature and humidity. So what is the purpose of these guidelines? So you need to have a base purpose, a goal. Why are we doing this? So the guidelines are written with a common focus area, and the IT and environmental domain. You have why we doing this. This is for the guidelines are to be followed to optimize server efficiency, temperature and humidity. Basically, you want to have efficient server with minimum failures, maximum uptime, maximum server utilization, health of the server, by maintaining the temperature and humidity in the space where the server is being housed. You cannot have extreme high temperatures and humidity. That could lower the efficiency and the life of a server. So this is IT environment. Airflow management, it has hot and cold aisle containment, reducing bypass airflow. Basically, you need to manage the airflow because there's a lot of heat. If you are being in a data center, there's a lot of heat being generated by the electronic equipments, the servers, and different machinery, and you need to ensure these heat loads, the amount of heat generated is properly dissipated, so as not to have a very hot room, because that could reduce the efficiency or damage the servers in the long run. As power and cooling is the third important focus area. Efficient UPS, power distribution units and cooling systems like computer room air handling and computer room AC units are very critical to ensure a proper power and cooling system. operation, and then security of the data center facility. Physical security, you have access control. Logical security, you have network and data. So these are the two important security parameters we need to focus on: physical security, access control, and gate barriers, and logical security is network and data. Metrics, so last section is PUE, power usage effectiveness, and other benchmarks for performance. I'll get back to you with the PUE and the calculations also for our reference. And now let's get started with the international standards for data centers. What we are following, what we're going to study, and quickly glance over is the IEC 22237 or ISO 22237. That is the international standard 22237. It is a crucial international standard series defining guidelines for data center planning, design, construction, and operation. PDCO, planning, design, construction, and operation. So 22237 guideline is a crucial international standard series defining guidelines for data center planning, design, construction, and operation, focusing on key aspects. What does this guidelines, what do these guidelines focus on? They focus on key aspects like availability, physical security, and energy efficiency. The international standards IEC 22237 cover critical details on construction and power distribution. It is 22237-2 and 3 sections. Environmental control is IEC 22237-4. Security systems is IEC 22237-6, acting as a holistic framework for all involved parties. So I'll just give you a basic coverage of what holistic approach means. It covers all aspects of the data center ecosystem, not just IT equipment. So when you are going through the ISO 22237 series 1, 2, 3, 4, 5, 6, 7, you have a basic holistic approach, which means it covers all aspects of the data center ecosystem and not just IT equipment. So if the data center has IT equipment, if you're focusing just on the IT system, that's one part of it, but you have security control, lighting, alarming, temperature control, and different kind of water humidity alarm. So it's a holistic approach which covers all aspects. And classification systems uses a tiered system, a classes based system on availability, security, and energy efficiency to tailor requirements. And C is risk based assessment, requires users to perform business risk and cost analysis to determine specific measures needed. D is part-based structure divided into parts for different focus areas. Like I was mentioning, 22237 is a broad guideline framework ISO for the data centers, and it's divided into 1, 2, 3, 4, 5, 6, 7 parts. Part number 1 is 22237-1. General concept is it defines terms, models, and the overall framework. Number 1, it just is a broad definition and general concepts classification. It defines terms, models, and the overall framework. Part 2 is 22237-2. That is the building construction. It covers the physical structure. So remember, it's a kind of a tiered layer. When I mentioned number 1 is a 22237-1. It's just the general concept, guideline, definitions, terms, models, framework. Number 2 is building construction. You have the physical site ready. Now you're going to construct the building. It covers physical structure. IEC 22237-2 covers the building construction guidelines and detailed information on how to proceed with the guidelines. Part 3 is IEC 22237-3, power distribution, power supply distribution. Power supply distribution, basically it's about power. So number 1 was general information, general concept. IEC 22237-2 was the building construction. IEC 22237-3 is power distribution, power supply, and how the power is being supplied to this building which is now constructed. Part 4 is IEC 22237-4. It's an environmental control, basically where because we are the controls people, so for us it's a particular focus because it's about part 4 is about temperature, humidity, airflow, HVAC, environmental control. What kind of cooling systems are we using? What is the temperature regulation? What is the temperature being maintained? Humidity and airflow. Do we need Lieberts? Do we need computer room AC units from Liebert or Stulls, or do you need computer room air handling units for larger data center spaces to cool the spaces? Part 5 is telecom and cabling infrastructure, IEC 22237-5, telecom and cabling infrastructure. So once you have all the buildings, you have the general information framework, and then you have the building construction, then you have the power distribution, you have the power, and you have the environmental control, where you have the BMS, CCTV, access control, temperature, humidity, airflow, all the HVAC parts. Part 5 is telecom and cabling infrastructure. Part 6, 22237-6 is security. Now we've got all the systems in place. You need to secure the perimeters, the premises, and make sure there's access control, physical security, and biometrics, and also the network security. Last part is IEC 22237-7 is the management on operation and the operational processes being used to ensure that the data center is running optimally and the energy is being conserved, and then we are using the right methods to cool the space, and you're not compromising the data integrity, and you're making sure the servers are operational in an optimum way. So these are the 1, 2, 3, 4, 5, 6, 7 7 parts of the data center framework guidelines. Who can you refer and use the IEC 22237 guidelines? That's a quick glance at whom is it intended for. It could be owners, operators, facility managers, engineers, architects, designers, and auditors involved in data center projects. So it's a good reference guide for anyone basically who is interested to know about data center operation, be it construction, be it technical field, be it HVAC, mechanical, electrical, plumbing, or building site. Is for all of the different stakeholders, parties, vendors, just to get information. They can get a good glance and knowledge about the ISO 22237 guidelines. Okay, I'm gonna just start with the ISO 22237 sections in detail, just a kind of a slightly more detailed explanation of each of the sections. I mentioned ISO 22237-1, information technology, data center facilities and infrastructure. Part 1 is the general concept. This document for general concept basically describes the general principles for data centers upon which the requirements of the ISO IEC 22237 series are based. B, defines the common aspects of data centers, including terminology, parameters, and reference models, functional elements, and their accommodation, addressing both the size and complexity of their intended purpose. C, describes general aspects of the facilities and infrastructures required to support data centers. D, specifies a classification system based upon the key criteria of availability, security, and energy efficiency over the planned lifetime of the data center for the provision of effective facilities and infrastructure. F, and the last one, provides a reference to the operation and management of data center. So that was 22237-1, the general framework and the concepts, general concept. Part 2, 22237-2, that is the building construction. The ISO IEC TS 22237-2 specifies requirements and recommendations for the following: A, location and site selection, building construction, building configuration, fire protection, quality construction measures. ISO IEC 22237-3, third part is power distribution. So 1 was the general concept, 2 was the building construction, part 3 is the power distribution. You have the building, now you need the power so that the building can run. The IEC 22237-3 addresses power supplies to and power distribution within data centers based upon the criteria and classifications for availability, physical security, and energy efficiency enablement within ISO IEC 22237-1. ISO 22237-3 specifies requirements and recommendations for the following: A, power supplies to data centers. Basically, this specifies requirements and recommendations for A, power supplies to data center, power distribution systems within the data centers, facilities for both normal and emergency lighting. D, equipotential bonding and earthing. E, lighting protection. F, the last one, And the segment 3 is devices for the measurement of the power consumption characteristics at points along the power distribution system and their integration within management tools. So that was part 3, power systems. Part 4, ISO IEC 22237-4. Part 4, remember, this is our concerned department, environmental control. So basically BMS, energy saving, HVAC will fall into this category. ISO 22237-4 is ISO IEC 22237-4. It addresses environmental control within data centers based upon the criteria and classifications for availability, security, and energy efficiency enablement within ISO 22237-1. ISO 22237-4 specifies requirements and recommendations for the following: temperature control, PMS, HVAC; B, fluid movement control, pumps, valves; relative humidity control, BMS, HVAC. Part D is particulate control, HEPA filter, or what filters we use to ensure that not enough dust, debris, or particulates are entering into the more sterile environments in the data center. E is vibration dampers. F is floor layout and equipment locations. And G is energy saving practices. And H is physical security of environmental control systems, basically. So that is part 4, and that is what the part 4 specifies on the requirements and recommendations. Okay, part 5 is about communication, telecommunication cabling infrastructure. So remember, this ISO 22237-5 is telecommunication cabling infrastructure. ISO IEC 22237-5 specifies requirements and recommendations for the following: information technology and network telecommunication cabling, SAN and LAN. B is general information technology cabling to support the operation of the data center. C is telecommunications cabling to monitor and control as appropriate power distribution, environmental control, and physical security of the data center. D is other building automation cabling. E is pathways, spaces, and enclosures for the telecommunications cabling infrastructure. Coming to the second last, the 6th is ISO 22237-6. This is the security system we are needing in the data center. This standard, section 6, specifies requirements and recommendations for those data center spaces and the systems employed within those spaces in relation to protection against: A, unauthorized access, addressing constructional, organizational, and technological solutions; B, fire events igniting within data center spaces; C, other events within or outside the data center spaces which would affect the defined level of protection. All right, so level 7, the last level in the ISO standard guidelines, ISO 22237-7, management and operational information. This ISO specifies processes for the management and operation of data centers. The primary focus is to aim at operational processes necessary to deliver the expected level of resilience, availability, risk management, risk mitigation, capacity planning, security, and energy efficiency. The secondary focus is on management processes to align the actual and future demands of users or clients. So that completes the ISO 22237. I'll be actually posting this in my video, ISO 22237 series data center international operational guidelines. So that's 2 parts we've covered today: the data center level 1 to level 5, red, yellow, green, blue, white tags, and the ISO guidelines being used. Thank you for watching, and I'll be back with another series explaining the data center infrastructure, the types of data centers, the main components of a data center, systems and solutions in the data center standards, data center tier levels, and aspects of data center design will be in my next video. Thank you for watching. Hope you've learned, and these are the basic concepts I'm covering just for our reference. Thank you.